Let's continue on with stage 3 of our canopy design. In the last movie, we created the arrays and set up array parameters to control those arrays. However, we left off with needing to do the math manually to determine the right quantity of awnings to go along with the right quantity of brackets. Furthermore, the length of the canopy factors into the decision of what the quantities should be, and it seems like all of those things we can do just a little bit smarter. So there's really 2 approaches we could take to clearing that up. One is using a feature we already know about, which is family types. So I could open up the family types dialog, and I could create a new family type. And the one that I have right now, the controlling dimension is 40 feet long. So I could call this 40 long and click OK. And that names what we have here. And we've already done the math and figured out that we need 9 and 8. Now suppose I wanted a 30 long. So I could go in here and put in 30 long, click OK, change this to 30. But of course, when I do that, it has no impact on my 8 and 9. I would have to manually say, well, for 30 feet divided by a 5-foot awning, I need to have 6 awnings. And therefore, to make the number of brackets make sense, I need 1 more of those. And so I do 7 there. And when I click apply, you will see the whole thing update, and it will do it correctly. And so if you don't mind doing a little bit of math, family types can be an easy and effective way of managing the various sizes and making sure that everything comes out okay. Trouble is, all 3 of these parameters have to be in exact sync with one another in order for it to make sense. If somebody accidentally puts in the wrong quantity here, you're going to end up with some strangeness. So that's certainly one way that we can do it, but there's a slightly better way. So let's look at one really quick example. Over here in the formula column, you can actually write formulas using a variety of techniques. You can use simple arithmetic or even more advanced trigonometry or if-then statements and so on to relate one parameter's value to other parameters in the file here. So if we know that the number of brackets always has to be 1 more than the number of awnings, probably the simplest formula that we could write is number of awnings plus 1. When I press enter there, it will apply that feature here so that if I were to change the number of awnings here to something else and just click anywhere else to apply that, you'll see that'll automatically go to 8. Now, when you do a really simple arithmetic formula like this, it's reciprocal. Okay, it works both ways. So if I change the number of brackets, it'll actually do the math in reverse, and I end up with number of awnings always being 1 less than the number of brackets, or to say that another way, number of brackets is always 1 more than the number of awnings. This doesn't free me from having to consider the right quantities here relating to the canopy length. It just simplified just a little bit by making sure that I didn't have to do all 3 things. So I now only have to adjust 2 of the values. Now, using that same logic, you could say, well, if I know how many awnings and brackets I want, then I could say, what if I take the number of awnings and multiply that by the size of the awning? So the canopy length could now be the number of awnings times 5 feet. And when I press enter here, what you're going to see happen is that will change to 25. And so now I've got myself a situation here where if I dial in a new number here and click apply, everything else will adjust, the canopy length and the number of brackets. So it's all kind of tied together. So I could certainly stop here, and it's a lot more intelligent than it was just a few moments ago. A couple of tips. Number 1, make sure that when you type your parameters in your formulas, you type them exactly the way that they are written. Number of awnings has to be exactly like it's written here, including case. So I had to use uppercase N, uppercase A, otherwise it will not work. If I change even one letter and I click somewhere else, it will say this does not work and they're case sensitive. So that's the first thing, and that would be pretty obvious the first time you do it. So check carefully. There's lots of other little places where formulas can break, so make sure you dot all the I's and cross all the T's. Now the other thing is, there's nothing about these formulas that prevents me from choosing a bad number of awnings. Now what would be a bad number of awnings? Well, 3 is okay, apply. 2 is okay, apply. What happens if I go to 1? Well, that's going to generate an error because you can't have an array with only one element. Okay, so that basically breaks the entire array. So let me cancel that, and let's set this back to at least 2, and talk about how we can fix that. Now, there's 2 ways you could approach it. You could just simply tell all your users, don't do fewer than 2 awnings, and create family types that are set to valid values and just hope that they don't break it. Or if you want to actually have the software do some of the error checking for you, we can actually create a really simple conditional statement using an if parameter to have it check the number of awnings that we place in there and put in the correct value. And it would go something like this. If the number of awnings is less than 2, then make it 2. Otherwise, go ahead and use whatever the number of awnings is that the user input. And what I've done is, something that I like to do as a strategy is, you've got this tiny little formula field over here. It can sometimes be tough to type in there, especially when errors are being generated and so forth. So I like to figure that out a lot of times in a simple text file or even an Excel spreadsheet, just somewhere outside of Revit, write it out, make sure I've got it right, and then copy and paste it into Revit and check it that way. So here I have that if statement in a notepad, and it just says if number of awnings, again being case sensitive, is less than 2, and then you use a comma, and then this is the condition if true, and this is the condition if false. So if the number of awnings is less than 2, then what we're saying here is use the value of 2. Don't let it go less than 2. Otherwise, it can just use the number of awnings. So I'm going to go ahead and copy that, Control-C, and I'm going to come back here to Revit, and I'm going to add a whole new parameter for this. You may have saw in Notepad that I was calling it array param. This has to be an integer property because the array parameter is just a whole number. And usually these error checking ones, you'll see a lot of family authors put them under other. That drops it all the way to the bottom of the list and kind of hopefully keeps snooping hands out of there. You know, they're trying to keep end user from messing with the formulas. There's no way to lock them out. So the best that you can do is just kind of make it hard to get to. So when I click OK here, there's other. It's currently set to 0. And I'm going to do Control-V right here. And let me enter that and see if I got it right. And you'll notice that this grays out and it went to number 2. So now let's test it out. Here's number of awnings. Let me go to 4. Click Apply. Notice that changes to 4. Let me go down to 1 and click Apply. Now, we haven't yet fixed what we need to fix here, but notice that the array parameter stayed 2, even though we're getting the error message. So we're going to deal with the error message next. But this says 1, and this said, yeah, 1 doesn't work. Let me go to 2. So let me cancel here. Let's reset this back to a valid value. Let's apply that, and then let's click OK. To use this now, what do we do? Well, now what we do is we come in here. Now we go back to our awning family, and we select on it, highlight its group, and click the array. There's our number of awnings parameter that's currently labeling that array, and we're going to change that to the array param. So instead of number of awnings driving that parameter directly, we're going to drive it with the array param, which does the error checking. And so now if I go back and let's test it out. There's still one more thing that we need to do here. If we want the array param to now do the error checking, we have to make sure that that's the parameter that's actually driving the entire family. So notice here that the number of brackets and the canopy length are still being driven by the number of awnings. So we need to change that. So the number of awnings will now use array param, and the number of brackets will also use array param. And again, remember to type them case sensitive. So let's apply that, and let's try some other values. Here's 5, should be working. Let's go all the way down to 1 and apply it. And you'll notice that array param says, nope, can't go to 1, we got to go with 2, and the canopy will react accordingly and still show us a valid array of 2 awnings. We end up with 3 brackets. So those are some examples of using formulas to drive parameters, both to simplify your input and the math that you have to do, make it a little easier to let Revit do the math for you, and also using a simple if statement to actually do some error trapping so that you can't inadvertently put in a value that's not valid and break your family.